Hi, this is a tricky rational equation to solve, and so you should pay attention to follow the solution right to the end because we are going to show some possible errors that should be avoided. All right, so we have root 50 all over 5 is equal to root 2 all over x to solve for x. Okay, so if we look to see at the numerators, we have this third here and that third there. So we already know the operation that we can take to remove the square root sign. So we simply square the numerator, we simply square both sides. So let's square both sides in order to remove the square root signs. Okay, that's the operation that removes square root signs. So you can see the square cancels the square root there. The square cancels the square root there. Remember, we also square the denominators. So this gives us 50 all over 5 squared is equal to 2 all over x squared. And 5 squared we know is 25. So we have 50 all over 25 is equal to 2 all over x squared. 25 here 1, 25 there 2. All right, so we end up having 2 all over 2 all over x squared. Okay, this 2 can also be written as 2 all over 1. So we see 2 on both sides, so we simply can divide both sides by 2. And dividing both sides by 2 is the same thing as multiplying both sides by a half. So if we multiply both sides by a half, all right, we see the 2 cancels. And so here we're left with 1 all over 1 is equal to 1 all over x squared. All right, so from here, if we carry out cross multiplication, all right, so we're going to have x squared here is equal to 1. Okay, so if we take now the 1 from the right hand side to the left hand side, we obtain x squared minus 1 is equal to 0, which is a quadratic equation. So we expect to have two solutions. Looking at the left hand side, we can see that it's actually a difference of 2 squares because 1 can also be written as 1 squared. Remember, 1 squared is the same as 1, but we'll just write it like this in order to see clearly so that we can be able to apply the difference of squares identity. The difference of squares identity. So when we do this, when we apply this identity, we're going to obtain x minus 1 into x plus 1 is equal to 0. From here, we see that x can either be 1 or x can be negative 1. Now, we should be careful. This is where the error can come in. Someone can get to this level and just conclude that our two solutions are x equals 1, x equals negative 1. But we have to be careful. Actually, one of these solutions is not right for our rational equation. Remember, we were given the rational equation and not the quadratic. Okay, with the quadratic, we obtain our two normal solutions for this quadratic. These solutions are valid for this quadratic equation, but are all these solutions valid for our rational equation? So we have to check to be careful. Now let's check when x is 1. When x is 1, let's put it there. We're going to obtain root 50 all over 5 is equal to root 2 all over 1. Okay, simply means it means that root 50 all over 5 should be equal to root 2. So let's check what is root 50 all over 5. Do we have root 2? Okay, do we have root 50 all over 5 equal to root 2? Let's check. Root 50 can be written as root 5 times 10, which is the same as root 5 times 5 times 2. Okay, this gives us root 25 times 2. And root 25 is simply 5. Okay, times root 2. Remember, everything was divided by 5. So which gives us root 2. All right, so when x is 1, the left hand side agrees with the right hand side. So x equals 1 is a valid solution. Now let's check when x is negative 1. When x is negative 1, let's see if the left hand side is going to give us the same result as the right hand side. Already the left hand side, this analysis told us that the left hand side is root 2. Now, if we put x equals -1 on the right hand side, we're going to obtain root 2 all over -1, which is simply negative root 2. And root 2 is not equal to negative root 2. Hence, x equals -1 is not a solution. So the only valid solution for our rational equation there is x equals 1.